Our team studied varying self-checkouts across different businesses found within a standard mall, such as clothing retail, grocery stores, and pharmacies. Main problems we noticed with users included conflicts in reaction and response times, or unclear expectations, frustrating information, and not knowing what steps to take next. Our diverging exploration into our sub-questions looked at a wider range of shoppers, with different age demographics from teenagers, adults, and seniors, and even their emotional states, such as confused, overwhelmed, and struggling. Leading us into our main overarching research question: how do the cognitive demands of self-checkout interfaces make them hard to learn and use? And what interface changes reduce that difficulty for different users?
How can self-checkout interfaces be redesigned to better support seniors with limited experience with technology? Self-checkouts are designed to deliver clients a fast experience with no assistance, but seniors have trouble with this because they're not familiar with technology, they understand instructions slower, and they need to do one task at a time. My persona is Nancy, a 70-year-old woman that does weekly grocery shopping, that lives by herself, and has no technology experience. She struggles with self-checkouts because it's overwhelming, small text, small buttons. The machines require fast interactions because there's people behind in line and there's too many tasks to do at once. My solution is to add 2 to 3 senior mode self-checkouts to help with their independency and so we don't interrupt other user experience by making the line slower. These machines will include larger text, larger buttons, brighter colors, icons, one instruction at a time, enough time to read instructions, and a big help button in case assistance is needed. Upsides is that it's a user-centered design and adapted technology to the needs of a specific group of people. Downsides is that the store needs to buy extra machines, and also seniors might still prefer older methods because of their cash payments.
Our second sub-question research looks at how might we redesign to better indicate and identify what similar items are listed under which names within the total purchase, creating a faster process. Our design solution addresses shoppers who might be accompanied with a few others, such as children or those purchasing in large quantities. Based on user experiences, pain points fell on telling apart multiple items within the same basket from their simple descriptors. This specific design solution modifies contextual content to each row of product, such as size, color, and style, highlighting one key image, and focusing on aiding users to recognize familiar items rather than recalling exact descriptions. Upsides to this design solution are establishing consistency in stylization to the website format, ability to quickly see what items they wish to remove or see if it's on sale. And it's easy for multiple people standing in front of the screen to see what has been scanned. Downsides to this design: it requires each line to be a lot larger and reduces the amount of items one person can view within the screen. And it also may contain extra information that users find not needed.
For our third sub-question, we asked, would a simplified express checkout flow with minimal prompts reduce confusion and improve checkout confidence for new customers? My persona is Leo, a high school student who is comfortable with tech and familiar with online shopping. He only purchases small items, so he expects the self-checkout service to be fast and concise. However, the self-checkout process can still feel slow and information dense. As such, my proposed solution is a beginner-friendly customer express checkout mode. At the start, users can choose between this mode or a regular checkout. The express flow keeps the process simple. Scan the items, review the bag, tap to pay, and finish. I designed the interface to feel more like mobile checkouts that younger users are already familiar with. The rounded buttons, simplified cart layout, payment icons, and tap to pay focus are meant to make the checkout feel more familiar and less intimidating. The main upsides of this solution is that it makes small purchases feel faster and less cluttered. The changes reduce memory load because the process is iterated step by step with no unnecessary prompts. However, it mainly works for users with 1 to 5 items and those who do prioritize tap payments. Additionally, stores may also not like that rewards or donation prompts are less visible.
My sub-research question is, how do weak and unclear feedback signals on self-checkout interfaces interrupt users, and what feedback changes let them fix the issue on their own? For context, this is still Leo to self-checkout, and he's there for a quick purchase and expects it to be fast. The problem is that the machine keeps stopping him with signals he can't act on. For example, a vague error like unexpected item in the bagging area does not really explain what went wrong or how to fix it. Or when the machine is waiting for him to bag an item, it doesn't really make it clear. The solution is to redesign the feedback following Norman's principle of closing the loop between action and result. First is to replace the vague error with a clear message that names the likely cause and suggests a fix. The second is to show the machine's current state with a short prompt such as place the item in the bagging area to keep scanning. These aftershots show the redesign. The error message now explains the cause and the fix, and the prompt at the top of the interface tells the user what the machine is waiting for. With the upsides, it lowers stress and confusion for users, helps them stay independent, and is inexpensive. As for the downsides, it adds more screen clutter, it doesn't fix a faulty sensor, and the system can't always name the exact cause.